Hi guys. I found some stuff around my house, and a lot of it is organic, and so I thought we can kind of talk together about what type of functional groups are in there. Now, we only studied about 10 functional groups, and there are hundreds of them, so we didn't really cover everything, but we can talk about some of the stuff that's there. So I'm going to start with, I found some food coloring. And so we didn't really study the molecules that make the different colors, but those colors are actually solids and they're dissolved in something. I wonder if any of you know. If you use food coloring, they always tell you, if you're cooking and you're going to add food coloring, you always have to remove it from the heat before you add the food coloring. That's because it's dissolved in alcohol. So one of the functional groups that are in there is alcohol with an OH. Here is some vinegar. Do you guys know what functional group that is? So this is acetic acid. It's 3% acetic acid. So that's a carboxylic acid with a C double bond O and then an OH. So anything that tastes sour in your food is a carboxylic acid. Lots of foods are slightly acidic. Here is some nail polish. So whether it's nail polish or a nail polish remover, you probably are familiar with acetone. Acetone is the solvent that we use to dissolve the nail polish. It is also one of the ingredients in nail polish remover, so that it dissolves it and removes it from your nails. So that's a ketone. Acetone would be a ketone, C double bond O. Let's see what else. I have some lime. So this has lots of stuff in it that we haven't really studied yet, but definitely you can tell that it's sour, and so that tells us there's carboxylic acid in there. Citric acid is what gives it its sour taste. Also, lemons smell pretty good, right? They have lots of essential oils that smell very good, and so it has esters in it, the good smelling stuff. It has some oil in it, which is some alkenes or alkanes, fatty acids. So it has lots of stuff, but the ones that we've studied probably are esters and carboxylic acids because they taste sour. Here's some rubbing alcohol. Isopropanol is what rubbing alcohol is, mixed with water. And so isopropanol would be an alcohol, has an OH in it. Let's see what else. I have some vanilla extract here. And so again, we have our esters that taste good, smell good. But then also this is dissolved in alcohol as well. Again, just like the food coloring, they tell you when you're adding flavorings or food coloring, you got to remove it from the heat before you add it. Because it's dissolved in alcohol. So you don't want to have like a flambe in a big fire. So you always remove it from the heat before you add any of your flavorings or extracts. Same thing with perfume. So perfume, what smells good? These are esters, probably a mix of different esters together, but it's also dissolved in alcohol because alcohol is very volatile, dissolves or evaporates very fast. And so when you spray your perfume on you, the alcohol evaporates really fast and it leaves the esters on your skin. So the point of dissolving in alcohol is to just get it to transfer easily to be on your skin. And then the alcohol evaporates, leaving the esters. And then I have some butter and some olive oil. So these are polymers. They're probably really big chain fatty acids that we haven't really talked about that much. You probably maybe talked about it in biology, but you hear about saturated and unsaturated fats. And so these are long chains that look like alkanes or alkenes with a fatty acid group at the end, but the main chain is either an alkane or an alkene. And so the ones that are saturated, those are the ones that have lots of hydrogens in them. They're full of hydrogens. So they're going to have a higher molar mass. And so they tend to be solids at room temperature. So this is probably a long chain of saturated, which means probably alkanes, and with a fatty acid group on it. Whereas things that are liquid at room temperature, those tend to be unsaturated, because that means they don't have as many hydrogens on them. And so they don't have as high of a molar mass for the same size chain, because they don't have as many hydrogens. And so they tend to be liquids at room temperature. So oils tend to be unsaturated, whereas butter and lard and things like that tend to be saturated. So I wanted to show you a picture actually of olive oil. So olive oil is a mixture of different things, but this is one of the things that's in it, and you can see it has double bonds in it, it has a ring in it, and so that makes it unsaturated, again, which causes it to have a lower molar mass relatively, and so that's why it's a liquid at room temperature. So these are just some things around my house that I found. Maybe you can find some other things around your house as well, and kind of think about the chemistry of these things. All right, see you guys later. Bye.